Okay, now we will just do a little bit of problems based on the set of point loads. So, first problem. Okay, I'm not going to write the whole question, but we have here 4 point loads. Okay, there are 4 point loads: 8, 15, 15, and 10 kilonewton. There are 4 point loads. They have a center of center spacing of 2 meters between consecutive loads, and they traverse a girder of 30 meter span. Okay, so it is given that the girder is a 30-meter span from left to right. Okay, so the loads are moving from left to right. That is very important. With 10 kilonewton load leading. With 10 kilonewton load leading. Okay. You have to calculate. Now, what you have to calculate is you have to calculate the maximum bending moment and shear force at 8 meters from the left support. Okay, this is the question. So they will be giving you a descriptive question. So it is very important to read the question very carefully and then make a sketch of the given data. So they have given that 10 kilonewton load is the leading load and the loads are moving from left to right. So that means 10 is leading. So 10 coming first. Then after 2 meters, you have a 15 kilonewton load. After another 2 meters, you have the next 15 kilonewton load. And again, after 2 meters, you have the final last 8 kilonewton load. This is the figure. Okay. Okay. Now, yeah, let me just erase this. Okay. Yeah. Now, they have also given something about the girder. So the girder actually has a span of 30 meters that is given. Let us name it as AB. Okay. And you have to calculate this at a section. So at 8 meters from the left support, that is from A, 8 meters from A, you have to calculate what are the maximum bending moment and shear force. So let us first sketch the ILD because it is with that you will be solving these problems. So I am going to draw the ILD for shear force first. Okay, ILD for shear force like this. And this is L minus Z by L and this is simply Z by L. Okay, so now, like I told you, you have to do a few trials. So at first, in order to get maximum negative shear force, so I'm starting with the solution. First one is shear force at section C. Shear force at section C. So I'll start with maximum negative shear force at C. Okay. For maximum negative shear force at C, you have to place the set of loads to the left of C and nothing is crossing C. But you have to check when one load crosses C whether there is a much negative value coming up. Sometimes that can also happen. So in the same figure, what I'm going to do is I'm either you can show it in the same figure or I will just draw another figure here showing only the ILD diagram. Okay, so I'm going to place, this is your section C. So I'm going to place 10 kilonewton here. And then after 2 meters, there is the 15 kilonewton, another 2 meters, 15, and finally 8. So these are all 2-meter spans. So you have the corresponding ordinates here. Okay, so this is 2, 2, 2, and 2. I mean, that need not be 2. This is 2, 3 are 6, 7, 8. Now it is exactly 2, 2, 2 each. So all these ordinates you can name y1. Let this be y2. This is y3 and this is yc. I'm going to take it as yc. So first let us find the maximum ordinate. Yc is given by z by l. Z is 8 and L is 30. So 8 by 30 is 0.266. Okay. And for finding y1, y2, y3, you have to use the principle of similar triangles. So y2 divided by yc is equal to 4 divided by 4 divided by uh, 8. 4 divided by 8. So this gives y2 as 0.133. Okay. Similarly, y1 divided by yc is equal to 2 divided by 8. So that gives me y1 as 0.0666. Similarly, there's one more to be found out, which is y3 divided by yc is equal to 6 divided by 8, which gives y3 as 0.2. Okay. With these values, how to find maximum negative shear force? Therefore, maximum negative shear force at C is equal to, you check the figure, each point load multiplied by the corresponding ordinate. So I will write 8 into y1 plus 15 into y2 plus 15 into y3 plus 10 into yc. So substituting, you will get 8 into y1 is 0.0666 plus 15 into 0.1333 plus next 15 into y3, that is 0.2 plus 10 into 0.266. So this will give you, the answer is 8.199 kilonewton. So it is as easy as this. Next, second one is maximum positive shear force at C. For this, again, I'm going to sketch the ILD figure alone like this, and you are going to show the set of point loads. So one load should be at C, or you can do actually one more trial, but for maximum negative shear force, I think this will be the maximum value. But for positive, you have to do one more trial for sure. So this is 8, then after 2 meters 15, after 2 meters 15, and after 2 meters 10. So this will be 2 meters. This is another 2 meters, and this is another 2 meters. What about this? 2, 2, 4, 5, 6. So rest of it is 16. Okay. So now let us mark this as, I am going to mark this y1, this be y2, this is y3, and finally y4. Okay. You have to now find what is y1, y2, y3, and y4. So referring to this figure and from the principle of similar triangles, we can find out just like how we did earlier. So how to find y1? y1 is nothing but L minus Z by L. So that is 30 minus 8 divided by 30, which is 22 by 30. Okay, it's okay if you don't get the decimal value. Now, next is y2 by y1 is equal to 20 by 22, which implies y2 is equal to 2 by 3. Then, y3 by y1 is equal to 18 divided by 22, which gives you y3 as 3 divided by 5. Similarly, y4 by y1 is equal to 16 by 22, which gives y4 as 8 by 15. Okay. With all these values, what is the maximum positive shear force? Formula is shear force at C is equal to load into ordinate value. So 8 into y1 plus 15 into y2 plus 15 into y3 plus 10 into y4. That is equal to 8 into 22 by 30 plus 8 into 2 by 3 plus, oh no, I'm sorry, it's not 8, it is 15. 15 into 2 by 3 plus 15 into 3 by 5 plus 10 into 8 by 15. So this gives an answer of 30.2 kilonewton. 30.2 kilonewton. Now let's check one more trial, that is let the this 15 also um, third load 15, let it be on C, and let this 8 come remain at the left of C. So I'll just check for one more position where I'm again drawing the ILD for shear force, and this time the position is like this. Okay, the second, third 15 kilonewton is at C, 8 is to the left of C, then you have 15 and 10. Okay, let us check if what is the value. Maybe this one might give some more value. We can't know. So this 8 is now in the negative shear force place, and this 15 is there, this 10 is there. So let this be y1, then this is y2, and this is y3. Okay, this value you already know. So here let us again check. Maybe you can write here check for another trial. So maximum positive shear force at C for this case is nothing but 8 into y1. Now since it is in the negative shear force, you have to give minus here. So minus 8 into y1 plus 15 into yc plus, okay, I'll write this as yc, plus the next 15 into y2 plus 10 into y3. Okay. This time the values will be different. So I'm not going to take time in finding each and every one. So you can actually look at the figure and find out. Okay, so directly we'll substitute. Now we are writing minus here, and we didn't write in the earlier things because in the negative shear force, when we were finding negative shear force so far, we just were taking the negative shear force in the negative shear force zone alone. We have not done this. I mean, we have not dealt with a train of concentrated loads before. So if you had a UDL longer than span, you just let the UDL occupy the entire left of section. Whereas if it was smaller UDL, again you made sure that the UDL does not cross section C so that you get everything in the negative shear force. So there was no need to substitute or particularly write the sign because you're already reporting it as negative shear force. But here you are actually checking whether there would be a change in the value of positive shear force when one of the loads was to the left of C. So you're actually just trying to check. So it is important that among the positive shear force values and the ordinates, you have to substitute negative for negative shear force. Otherwise, there is no point in checking because one is in the negative zone and the other is in the positive zone. That is why we are specifying the sign here. Okay, so this will be equal to minus 8 into y1. You will get it as this was 6 and this is 2 meters because it's 8 meters totally. So this will be 6 by 8 into 8 by 30. Okay, I'm directly substituting here. Then plus, if you want, you can individually find out y1, yc, y2, y3 and then substitute here. Okay, so this will be 15 into 22 by 30 plus another 15 into 20 by 22 into 22 by 30 plus 10 into 18 by 22 into 22 by 30. So simplifying this, you get 25.4 kilonewton. As you can see, 30.2 is higher. So therefore, you can safely report maximum positive shear force value as 30.2 kilonewton. That was just a check to know if you will get a value more than 30.2. Okay.